Okay, I'm going to do an overview of the syllabus and the class for ITC 255. This is systems analysis. Basically, the times will be online and it'll be asynchronous, which means that I won't be giving lectures on Zoom, but basically, you'll just work through the assignments at your own pace, use the materials that I give you, ask me questions by email, or by using the discussion board. Excuse me. My office probably isn't really relevant at this point because I doubt if we'll be back in the building. But just email me and I'll answer as soon as you can. And if we need it, we can arrange some type of online meeting. And again, as I've said, if you need, you can also post to the discussion. We'll talk about that a little bit more. So there is a blog for this. There are YouTube videos too. I've posted them mostly, link them into the module, which we'll look at in a moment. So things that we're going to do, we're going to define what is meant by systems, explain the advantages and disadvantages of different methodologies, although you will do that mostly by reports, which we'll talk about later. We'll do a lot of UML, which diagramming objects and their relationships, and we'll talk about that in a moment. We'll code some aspects of it, and not a lot of code, but some code, probably in Python. Though if you want to use Java, it can probably be arranged. We're going to create and run some tests, and there is a little bit of group work, and I'm not sure how that will work in the current environment, but we will try it. You can work on your own pace. I don't take off for late assignments, though it's better not to get too far behind. Materials and videos will be made available, and again, email me or enter the question in the Canvas discussion. There are going to be presentations, and we're going to try to post them in the discussions forum so people can look at them. Okay, so we're going to go it without a book. So there's a lot of stuff online, and I will have a lot of materials for you. So attendance consists of continuing to work on your exercises, watching and contributing to the discussion forum, watching for alerts. Assignments and scenarios are assigned a point value, and they all have a rubric. If I take points off, I will always comment as to why, and you can correct the problem to get the full points. Then there's a whole bunch of other information about the school and services. Okay, so that's sort of the basic syllabus. Mostly you're going to want to look at the modules. So there's an overview module. I'm going to actually do the Google Slides one. Talk about lucid charts. So basically, lucid charts is probably the only software you will need other than Python. I think I have a list of things to cover here. For software, lucid charts, which is online, right? You don't have to download it or anything, and then Python. And there are some online versions of Python if you really must. And you can look those up. But those are the only two things that we will need. So there's an overview here. We start off by doing a simple database ERD, and there's a YouTube video for that. And I have a one on the blog, and then I'm just going to ask you to do a little bit of an ERD. ERD is an entity relation database design, or basically how you do the database designs. Then we're going to do use cases, and we'll talk about that. Use cases are UML. And again, I have the assignment, I have Google Slides, and I have a video, activity diagrams. I have the same kinds of things for that. Class-oriented design, object-oriented design, we'll talk a bit about those. And I may add materials to all of these as we go on, just to give you more information. So just to look at a basic assignment, let's look at the use case 1. So I have a description of the assignment, and then I have the rubric, right? So you can work at them, as I said, at your own pace, and you can ask me questions as you need. The other part I want to talk about are discussions. So there's a couple of areas for discussions here. Let's look at the use case 1. There's no message there, so that should probably go away. But you can post discussions there and questions that you have so that the class can answer as well as I. I will try to watch the discussion board carefully and look for what you need. Now, the whiteboarding is not relevant to us right now. I also think I want you to just post to your presentations here. One of the last assignments, let's look at that. Or we could look at it in modules, actually. It's probably easier to see there. One of the very last assignments is to do a presentation. All right. And what we're going to do with the presentation, that these will ideally be a group. They should only be about 15 to 20 minutes in length, although we're not going to actually present in the classroom. It should include a definition of the topic, a brief assessment of the context and importance of the topic, the main components or features of the topic, advantages or disadvantages associated. There's a list of presentation topics. It's also there in the module. And then we're going to upload any materials or links to discussions. And I also want a log of who did what, just partially to make sure that everyone that participates in the group gets credit, and that somebody that does nothing doesn't necessarily get credit. So, a couple of things about cooperating. So if you go to people, you will see under groups there are presentation topics for each subject. Couple of things. It's self-joined, so you can join whichever group you want. If you haven't joined by a couple weeks in, I will just assign you to a group somewhat arbitrarily. There's also under pages, there is the overview. There are presentation topics, and there are dates on these, but these dates are suggestions. I'm not going to hold you to them. All right. Basically, these presentations need to be in by the end of the quarter, but I would, some of them come earlier in terms of topic, and these are really going to be important. They give you the broad perspective of systems analysis, stuff that we're not covering in the actual assignments. And I'll talk a bit about that more in a moment. So, how do you collaborate on these when you're not together? Google Slides, Google Docs is a really good way to collaborate. You can also use collaborations. Ooh, I'll have to activate that for you, but I'll activate collaboration so you can use it. And however you can, just let me know too if you have problems. We'll try to figure this out. All right, so that's actually going to be the biggest challenge of these presentations. Okay, so I'm going to go back to modules again, and trying to think if there's anything that I have. Let's go back to pages. I may add some pages as we go. This is about Lucidchart and the other software. These are systems that are going to be used for the assignments. This is the one. These were actually going to be used for lecture, and you'll see some examples of this in my examples. but I'm not going to, and I might do some more lecture or stuff on video to give you related to these. The individual assignments are based on a project to create self-checkout kiosks. The goal is to make a new generation of those kiosks that can be easily customized and upgraded and which can be adapted to work in a variety of retail and service environments. I say all coding for both projects will be done in Python, but it could be done in Java if you prefer. Python is what most people know, so that's what we'll be doing in my examples. So the idea, this is what we're going to work on, is to try to analyze this system. What would these kiosks need? What would they, are they going to work? What are their features? How would you break it up into objects? We'll talk about all of that. Okay, so I'm going to go back to modules. And I'm going to do the Google Slides overview of systems analysis because probably most of you have only the vaguest idea what any of this is about. And this is meant just to orient you a little bit. So, you could do it here, but I'm going to click this little thing to go to the external link, and then I'm going to put it in present mode. Okay. So, systems analysis and overview. Okay, so systems analysis is the study of how to model and develop complex systems. Most attempts to create new systems fail. In fact, they usually say about 80 to 90% of new system attempts to create new systems fail. Systems analysis is is an attempt to create and develop techniques and tools that improve the chances of a new system succeeding. It includes a wide variety of skill sets, including project management, accounting, networking, and development. And in this class, we're going to focus mostly on the developer's perspective. All the other parts are important too, but we're going to focus mostly on the development side. A system is a collection of objects and processes that work together to achieve a common end. And analysis is taking that system apart to see what the pieces are and how they fit together. And then again, together, systems analysis consists of a set of tools and approaches to understanding and building complex systems. So the analysis usually begins when a system that has existed needs updating. It's no longer sufficient for the needs of the company or the organization, and or when a new system is needed because there are new needs that have arisen. The first step is defining as clearly as possible what the requirements of the new system will be and what is needed if the new system is to be successful. All right, so after you have the requirements, then you look at solutions and alternatives. For every problem, there's always multiple solutions. You might put it on Linux or you might put it on Windows. You might talk about using existing servers or creating a new server farm. These days you might also ask whether it's just better to put it on Amazon or Microsoft's Azure cloud. At the minimum, there's usually 4 basic alternatives. One is just to leave things the way they are, and that should always be considered as a possibility. Maybe it's sufficient to leave it as it is. You should, one option is usually just providing the very minimum to meet the needs that have been identified. And then there's one that provides for all of the needs, but also adds a lot of bells and features and builds in the ability to expand and grow, the full featured approach. And then there's usually a version in between. While it might seem obvious that the between solution is the best, that's not always the case. Sometimes it pays to build out all the features. And sometimes if you're in a transitional mode and you're not totally sure what the requirements will be in the future, it might pay to just do the minimum mode. So any one of these 4 options could be the correct option. You'd have to figure it out for the situation that you're in. So once you have identified different solutions, you should take each alternative and analyze its feasibility. There's financial feasibility. Is it going to pay for itself? How expensive is it? Technical feasibility. Does the software and the hardware exist? How expensive is it? Legal feasibility. Are there legal issues that could come up because of this? Cultural feasibility. Will our customers and our company, will they work with the new system? What issues is it going to raise? For instance, when you go to totally online banking, how many people will that alienate who like to deal with human tellers in the bank? Time feasibility. Can this all be done in a reasonable amount of time? We're going to discuss each of these in more detail in class presentations, hopefully. So these are some approaches. There's the traditional waterfall approach. There's Agile, which you've probably heard of, and there's DevOps, which is sort of the current one. And again, these should all be classroom presentations, so I'm going to hold off on them until they are presented. We're going to focus a lot on UML, which is Universal Modeling Language. And it's an attempt to standardize the kinds of diagrams developers use when describing systems and code. It's basically object-oriented in its focus for development and programming. And we'll look at 4 types. There's more types than this, but we'll look at 4 of them. Use cases, activity diagrams, class diagrams, and sequence diagrams. Use case is a diagram that shows high-level requirements. You know, what is it? And it looks at it in terms of particular actors. So here's an instructor looking at 2 use cases for the door lock system. The instructor needs to be able to access the door and request access. So we'll talk about these as we do them. Activity diagrams are similar to flow charts. They show how a process moves through certain actions and states. So we'll look at that also. That should be insert card, not cart. All right, class diagrams. These show the objects, and they show, in particular, the attributes which describe the object and methods which the object can do. So each one of these is the name of the object, the attributes of the object, and the methods, the functions in the object. Sequence diagrams talk about how objects communicate with each other, passing messages from one object to another and passing messages back. All right, so when we're done with this, we'll do a bit of coding. It'll be fairly minimal, and I can probably help you if you need. And again, if you want to use Java, let me know. Testing is a crucial part of all the development. We will do some basic unit tests to get a feel for that testing. And unit tests are tests which test to see if a method returns what is expected. All right, I think that's the end of that. So I don't know if that gave you a better overview or not, but that is kind of what we're going to be doing. So again, I would go to the modules and I would work through some of the overview stuff, figure out about lucid charts. If we look at that real quickly, to get lucid charts, you don't want to go to the start for free. You want to scroll to the bottom of the web page and choose education, and you need to register with your EDU email account. You are given one automatically when you register. I think that there's some of this in the videos. The education account is still limited, but it doesn't limit the tools. I think you're given 10 charts, and if you have done 10 charts and need another, you can delete one of your existing charts, and then you'll be free to create another. You can turn in a chart as an assignment providing a shared link to lucid charts, or you can save the chart as an image or PDF and upload the assignment. There are other programs you can use, like Visio if you really want to, and you're welcome to use them if you have them, but make sure I can read the diagrams when you turn them in. A lot of times it's better just to take a picture of it if it's not, particularly if it's not lucid charts. Other than working with Lucidcharts, the only other software you'll need is Python. And again, there are several other online versions of Python if you don't want to download it, but it's not a big download and it's nice to have. All right, I am going to end the video, and good luck and get started when you're ready.